Hello everyone. I hope you are doing well. My name is Ranjit Bade and I work as a technology manager at Tech Mahindra. Thank you for joining me today for this ACM demo. In this demonstration, we are going to take a look at and walk through a step-by-step setup of single node OpenShift with Red Hat Advanced Cluster Management. In this video, I'll guide you through the entire process, starting with installing and configuring an SNO Hub cluster. Then moving on, provisioning a remote spoke cluster, and finally onboarding a simple application. By the end of this demo, you will see how these steps comes together to showcase seamless end-to-end cluster management. Let's take a moment to spotlight Tech Mahindra's expertise in network services. With extensive experience spanning regions and continents, we serve telecom operators worldwide, leading the way from design to deployment and enabling seamless transition to cloud native architectures, empowering our clients to thrive in this dynamic new era. Tech Mahindra's core capabilities span five key areas: device engineering and certification, core and development, testing and integration, core networks deployment, integration, development and testing, management and orchestration, test and measurement. Let's talk about the synergy between Tech Mahindra and Red Hat. Tech Mahindra and Red Hat have forged a powerful global alliance with over 1,000 accredited specialists and 37 delivery centers. This partnership spans 20 plus countries, serving around 50 joint customers worldwide. As the telecom industry evolves, we are witnessing a significant shift from virtual network function VNF to cloud native function CNF powered by platforms like OpenShift. Red Hat OpenShift empowers the telecom ecosystem by delivering a unified container platform to deploy core network functions, RAN, ORAN workloads, and OSS BSS applications, ensuring the scalability, low latency, and seamless integration. Its hybrid cloud capabilities enable automation and flexibility across edge, regional, and central data centers. By leveraging Kubernetes based platforms like OpenShift, companies can streamline their operations and enhance their service delivery with microservice architecture, allowing for a rapid deployment cycles and seamless updates. So, what is the use case for OpenShift RHACM deployment in telecom operators for RAN and core networks? It has a powerful zero touch provisioning ZTP for rapid deployment. It has a centralized management for distributed RAN and core networks. RHACM simplifies multi-cluster management, governance, and application lifecycle across hybrid and multi-cloud environments, ensuring scalability, compliance, and automation for seamless operations. In our lab, we have Red Hat OpenShift version 4.17.18 and Advanced Cluster Management 2.12. We have three physical bare metal hosts, our HP DL380 Generation 10 servers. One of the bare metal hosts is running VMs, DNS, DSCP, NTP. Second one is running OpenShift with ACM hub install. And the third one will act as a single node OpenShift spoke cluster. In the following section, we will access the Red Hat OpenShift console to install the required operators, configure the bare metal inventory, and deploy a single node OpenShift cluster using a discovered host. This will be followed by the deployment of the application. Prior to this, we have provisioned four virtual machines on KVM, serving as a bastion host, DNS server, NTP server, and a DSCP instance. We have deployed a single node OpenShift hub cluster using the user provision infrastructure UPI method on a bare metal server. Accessing the OpenShift web console through the browser, we proceed to install the required operators directly from the operator hub interface. This is our OpenShift console. We will navigate to the operator section where select operator hub. Search for LVM to set up our local storage. Once located, install the LVM operator. The LVM operator on OpenShift provides a mechanism to manage persistent storage using logical volume management on nodes within the cluster. It provides dynamic provisioning, local storage management, storage classes, data resilience, and monitoring and metrics. By abstracting the complexities of LVM, the operator allows Kubernetes-based applications to leverage local storage efficiently in a declarative and manageable way. Post installation of LVM, we will then search for RHACM operator and follow the same process to install ACM operator. After installation, navigate to the installed operator section to verify the installations. Here, you will see both the LVM operator and the ACM operator listed, and the multi-cluster engine for Kubernetes installed automatically along with the ACM. In LVM storage configuration, go to the storage section and select storage classes. You will notice a dynamically created new storage class confirming that the LVM storage has been configured correctly. To enable central infrastructure management, we have to apply agent service config manifest file, which creates an agent followed by creation of two pods, namely the assisted image services and assisted services. These pods are created under the namespace multi-cluster engine. This action will dynamically provision two PVs, persistent volumes, and two PVCs, persistent volume claims. We verify this in the respective sections. With RHACM installed, begin by selecting the local cluster section in the top left corner. Clicking this section will open a drop-down menu where you can select the All Cluster option to access the ACM console. In the console, the local cluster is identified as a hub cluster. Next, we will create host inventory. Navigate to the host inventory section. Click Create Host Inventory and fill in the required details like name, network type, location, SSH public key, and pool secret. Click Create to finalize the inventory creation. We are now adding host. Go to Host section and click Add Host. Select the BMC form and provide the following details: bare metal credentials, IP address with Redfish API, and the NIC MAC address. Click Create to begin the host registration process. For this particular step, ensure that your hardware firmware supports Redfish protocol. Once the registration process is over, the host will move to the provisioning state. Now we will access the ILO interface of the HPE server to monitor and verify the BMC process. The server powers on automatically with an ISO image Ensure that the booting sequence on the server is correct. As you can see on the screen, the system boots into RHEL Core OS. It will take a while to boot the server completely. After booting, the host will appear in the inventory and turn the status to available state. This complete process may take around 2 minutes dependent on your server hardware. The Arcos has loaded now. The node has moved to available state. Let us start to deploy an remote OpenShift cluster. Navigate to cluster section and create cluster. Select host inventory, standalone and existing host. Provide the following details: cluster name, cluster set, base domain, OpenShift version to deploy, type of installation, that is single node, and provide the full secret. Copy the full secret and paste it. Review the input parameters. If the parameters are correct, save it. Add number of hosts you want to install. In our case, it's one host, single node OpenShift. Add networking details such as network type, available subnets, and provide host SSH public key. The host inventory may reflect in some invalidation. It will take a while to come into valid state. It is now ready for the installation. Hit on next. Review the cluster parameters and install the cluster. You can monitor the cluster events in the cluster event section. As we monitor the progress in the cluster event section, observe important stages like disk writing, installation, and the rebooting process. Wait for the installation to reach 100%. The installation process has been successfully completed, reaching 100%. To proceed, you can access the remote cluster console by clicking on the provided web URL for the console. Once the page loads, you will need to enter your login credentials to authenticate. After successfully logging in, you will be granted access to the remote cluster dashboard, where you can monitor and manage the cluster resources and settings efficiently. Now we can see two clusters on the ACM console. One is the hub cluster and the other is newly provisioned spoke cluster. Now we will deploy a sample web application on the provision cluster. In the ACM console, go to Applications and click Create Application. Choose Subscription and provide application name, namespace, repository type, GitHub URL, and all the relevant parameters regarding your GitHub. Specify the deployment cluster. In our case, it is SNS Spoke cluster. Click on Create to create the application. Navigate to Topology and locate the route. Click the Launch Route URL to view the application's front end. Thank you so much for watching this video.